Hello, everyone. This will be chapter 5, and the topic of this chapter is selecting research participants. So, suppose you volunteer to participate in a psychology study. And let's say that you're maybe one of 20 different volunteers, one of 20 participants. Now, surely you understand that the purpose of the study is not to study you specifically, nor the other 19 people in the study. To the contrary, the purpose is to generalize from this sample of participants and make some broad, sweeping claim about an entire population on the basis of this sample. Now, you may ask yourself, well, how is this possible? How is it permissible for psychologists to make such broad, sweeping, audacious claims about millions or even billions of people, given that the average psychology study has maybe a few dozen participants? What is this strange magic that allows for such brazen generalizations to be made? Well, you have to assume the following. You have to assume that if you take a sample from a population, it is in principle possible for that sample to capture the important properties of the population, even though the sample is only a tiny percentage of that population in its size. So basically, the sample becomes almost a mini replica of the population, such that what is true of your sample will also be true of the population. However, in order for this to happen, there are certain principles that need to be followed regarding the properties of the sample and the manner in which that sample was selected from the population. And so this chapter delves into those challenges. So this chapter is broken down into 3 sections. One is an introduction to the topic of sampling. 2 is probability sampling. And 3 is a non-probability sampling. And we'll learn what these terms mean in the appropriate section. And here's a limerick for you. There are problems in psych. For example, how does one select a good sample? Here's a quick memorandum. It ought to be random, representative, neutral, and ample. So this will be section 1 of chapter 5, which will serve as an introduction to the topic of sampling. We will discuss the relationship between samples and populations. We'll talk about representative samples. We'll talk about the importance of sample size and also discuss sampling basics. All right, so sampling is a really important aspect of research. Now, psychology is in the business of making very broad claims about large populations on the basis of pretty small samples. And the reality is, different samples collected using different approaches, different techniques, different methods, can yield different patterns of results. And this may limit your ability to make the generalizations that you want to make as a scientist. So for example, let's say you're conducting a survey about how Americans feel about some political issue. Maybe abortion, immigration, taxes, whatever. Well, if you take that survey in Los Angeles, you might get a different result than if you take that survey in Nashville, right? If urban areas are overrepresented in your survey, you may get a different result than if suburban or rural areas are overrepresented in your survey. So the question is, are you really justified in generalizing from your sample to the population? And depending on how that sample was collected, depending on how representative it is, the answer may be yes or no. So again, the outcome of a study will often depend on the methods used to select your sample. So with that in mind, let's formally define some of these terms that we've been using. Firstly, you have the population. And here, population doesn't mean every person on Earth. Rather, it means the people that you are interested in studying in the context of your research. So if your research is on people with clinical depression, then your population will be every adult that has clinical depression. If your research is on military vets, then your population will be all military vets. So again, the population can be very broad or very specific as dictated by your research question. Now, in most cases, the population will be very, very large. Thousands or tens of thousands or millions of people or even bigger. And of course, you can't study all of them, even if they were all willing to run in your study. So you have to take a small sample of manageable size from that population, perform your experiment on that sample, and then the goal is to generalize the findings from the sample to the population that you care about. So here on the right is a schematic of that process. So again, you have the population. That's all the individuals that you care about. You take a small sample of that population. You perform your experiment on that sample, collect data, analyze the data. You get your findings, and then you generalize the results and conclusions from the sample back to the population. Now, we also have to distinguish between different categories of a population. So firstly, there's what is called the target population. And the target population, that's the group of people that you care about. So again, if you're studying depression, then the target population is people with depression. Now, the problem is, in practice, you don't have access to every single person with depression. Instead, you may only have access to some people with depression in the local clinics or treatment centers. And this is the accessible population, the subset of the target population that you actually have access to. So these concepts are represented in this illustration here. So you have the target population, all the people that you care about. Now, a subset of that population is the accessible population, the people that you actually have access to. And so your sample is going to come from the accessible population. Okay. Now, you face two problems here. One, will your sample generalize to the accessible population? And maybe it does, and maybe it doesn't. But even if it does, that doesn't necessarily mean that the accessible population generalizes to the target population. But going forward, we will use the term population to refer to target population. So another term we've been using is representative. And so the representativeness of a sample refers to the degree to which a sample represents the properties of a population. And if you hope to generalize your results to the population, then you have to ensure that you're able to obtain a representative sample, which is, again, a sample with the same characteristics and properties as the population. Now, as we discussed in the previous slide, your sample is drawn from the accessible population, the people you actually have access to in practice. And that accessible population may not be representative of the target population. However, oftentimes the best you can hope for is to have a sample that's at least representative of the accessible population. So one serious problem, one serious obstacle to obtaining a representative sample is bias. And bias can leave you with a biased sample. Now, a biased sample is one in which the properties of the sample are significantly different than the properties of the population. And this can arise from several different factors. Sometimes it can happen just by chance. Or other times it can happen through what is called selection bias or sampling bias. Now, sampling bias occurs when the methods or procedures used to select your sample from the population favor some individuals over others. Okay, let's consider the following example. Let's say you're conducting a poll on how people are going to vote in some upcoming election. And let's say this is your population of all registered voters right here. And here, let's say you have their age distribution. So let's say 30% are 18 to 35, 30% are 36 to 55, and 40% are 56 to 80. Let's just say that's the case. Now, age is not the only thing that matters about voters, but it's one thing that matters. So this is your population, and of course you can't study all of them. So you have to take a sample, okay, a little bite from the population. And there's your little sample. Now, ideally, you want your sample to have the same properties and characteristics and demographics that the population has. So 40% of the population is between 56 and 80. You want approximately the same percentage of your sample to be between 56 and 80. And so here we can see we have a perfectly representative sample, at least in terms of age. Okay, so this is a representative sample. Now consider the following scenario. Let's say this is your sample. Okay. Now, if you look at the sample, you may notice, something is off. You may notice that older people, 56 to 80, are vastly overrepresented in your sample. And younger people, 18 to 35, are vastly underrepresented in your sample. So here, the properties of your sample do not match the properties of the population from which it was drawn. And so this would be an example of a biased sample. Now, is this a problem? Well, it depends. If age is completely irrelevant to voting behavior, if age is not a predictor of voting behavior or political affiliation, then maybe this is not that big a problem. But if age is related to voting behavior, then this could be a huge issue. And we know that age is indeed related to voting behavior and political affiliation. So on average, older people tend to be more conservative, and on average, younger people tend to be more liberal and progressive. And so if you have a sample that is overrepresented with older voters, then your sample will overestimate the popularity of the conservative candidate and underestimate the popularity of the progressive candidate. So this happens in the real world. I mean, traditionally, polls were conducted via phone calls and landlines. The pollster would call your house and ask you to participate in the survey. Now, over time, young people sort of stopped using landlines. And so what happened was, as a consequence, is that older people were overrepresented in these surveys and polls conducted using landlines. Older people were more likely to use landlines. They were more likely to be retired and be at home, had more free time on their hands. And so you had an overrepresentation of older individuals in your samples, which creates a biased sample, and it skews the conclusions that you draw about the population. So again, a representative sample allows you to make accurate generalizations from the sample to the population. With a biased sample, you will not be able to make an accurate generalization from the sample to the population. So, you want your sample to be representative of the population. Well, how do you do that? And one answer is the sample size. That is one critical component in selecting a sample that will be representative. And here we have something called the law of large numbers, which basically states that the larger your sample, the more representative it's going to be of your population. So larger samples will be more representative of a population than smaller samples. And intuitively, we can understand this. Let's say you have a sample of 1,000 people. Let's say you have a population of 1,000 people. And suppose you take a sample of one person, okay? That one person probably won't be very representative of the population. If you take a sample of 999 people, now it will be very representative of the population. And so as you increase your sample size from 1 to 999, the sample starts becoming more and more representative of the population. Okay, so here is a real-world example. Here I took a population, and the population were the students from a class that I taught in the spring, physiological psychology, and this is their performance on their final exam. So the population mean, the average grade on the final, in a group of 80 students, this was 2 sections, was 77%. Okay, so the average score in my class was 77%. Now what I did was I took random samples of different sizes from this group of 80 students, and for each sample I computed the average exam score in that sample. And I varied the sample size from 2 to 5 all the way up to 20. Okay, so looking at a very small sample size of 2 students, that's tiny. Again, each data point represents the average exam score in a sample of 2 students drawn at random from the population. And what you'll notice is that some samples come close to the population mean, but they're sort of all over the place. Okay? Some samples greatly overestimate the actual exam score, and some samples greatly underestimate the actual exam score, the population mean. Now, as you increase the sample size, what you notice is that the sample means begin clustering closer and closer to the population mean. And with a sample size of 20, basically all the means of all the samples come very, very close to the actual population mean of the entire class. So again, the larger the sample size, the better that sample will capture the relevant properties and characteristics of your population. So here we have another graph that makes a similar point in addition to another important point. So here on the y-axis, we have the average distance between a sample mean and the population mean. So the lower the value, the more similar the sample is to the population. So lower values are good, high values are bad in this case. And on the x-axis, again, we have the sample size from 1 to 100. And again, we find the same trend where increasing sample size increases the similarity between the sample and the population. But you see that this curve is not linear, okay? What you'll notice is you have huge improvements between, let's say, in increasing the sample size from 1 to, let's say, 9, massive improvements here, but relatively modest improvements from increasing the sample size from 64 to 100. So you sort of get a point of diminishing returns, where adding more people to your sample doesn't really help you that much, okay? The curve begins to level out. And so looking at this curve, really approximately 25 to 30 people is a good number. 25 to 30 people per group is typically enough individuals to capture the properties of the population. So that's what this curve is telling us. So recall when a long time ago, we discussed the topic of ethics in the previous chapter. Well, it turns out that ethics actually overlaps with the topic of sample size. How so, you may ask? Well, let me tell you. So for example, if your sample is way too large, then you are wasting people's time. You are wasting money. You are wasting resources. You are dragging people into your study when they don't really have to be there. And there are ethical implications of doing this. Now, on the other end, if your sample is way too small, then it is unlikely to be successful. It is unlikely that your study will be successful. And you are also, in this case, wasting time and money and resources. And any resources that are wasted by you are resources that could have in principle gone to some other better designed study. So wasting resources is also kind of unethical, given that resources are finite. So how do you determine the appropriate size of your sample? And really there are two approaches. One is that there are certain statistical calculations that we'll mention later in this course that can determine how many people you need in your study. And two, you can consult other similar studies in the scientific literature to see their sample sizes and choose a sample size that is close to theirs. All right, so we're going to talk about sampling basics. And this will introduce some of the topics that we'll cover in the next two sections. So sampling is the process of selecting individuals for your study from a population. And sampling falls into two categories. There is probability sampling and non-probability sampling. So probability sampling is when the odds of selecting a particular individual are known. And in order for this to happen, you have to know the exact size of the population, and you have to be able to list all the individuals in that population. Furthermore, the selection process has to be unbiased. And the way this is achieved is through a random selection process, a process that does not arbitrarily favor any one individual over any other individual for selection into your study. Now, the other category of sampling is called non-probability sampling. And this is when the odds of selecting a particular individual are unknown. And when sampling is based on ease or accessibility. Sampling people that you can get practically, pragmatically speaking. And sampling that's based on ease or accessibility may contain bias. Some people may be more likely to be chosen into your study than other people for arbitrary reasons. Now, in reality, most studies in psychology will fall into the category of non-probability sampling when the odds of selecting a particular individual are not fully known, and sampling is based on ease and may therefore contain all kinds of biases.